Hello, good evening, my dear active participants for tonight. Welcome to our Institution of Global Professionals free webinar. Thanks for joining us on this wonderful evening. Dear audience, I am your host for tonight. My name is Rohamina Palakad Kapoor, currently teaching and a journal manager at St. Teresa International College, Thailand. I am proud to be associated with IGP as a global member. I feel honored and privileged to host this wonderful webinar. It's my delight to welcome you all to our Institution of Global Professional free webinar. Thank you all for joining us today in this marvelous evening, and it's my humble request and pleasure to all of you to stay with us till the end, for I am sure you will have many takeaways and payoffs from this webinar. It's time you can like, comment, and don't forget to tag, share, and mention your friends in the comment box below, just like what you are doing now. Thank you so much. So let's watch and learn together. We believe that power is gained by sharing knowledge, not hoarding it. Once again, I am Rohamina, member in IGP from the Land of Smiles, Thailand. Okay, every day we have new participants joining with us, so I have to give a little concept about IGP. Institution of Global Professionals serves students and community resource, providing holistic social work and education to create a proficient generation. We believe that it's not effective to increase one's skills just by acquiring formal education. We provide effective training and consultation to generate proficient generation all over the world. We organize this webinar, training, offline, online courses by best and trained speakers, coaches from all around the world to create a best learning platform for you all. Because our mission is to empower people and enhance their skills. We have already completed 106 webinars successfully. We expect that all of you are getting a little bit benefited in personal and professional life, and we wish that you are all remaining with us in this long journey. Let me remind you once again to please don't forget to share, tag, and comment or mention your name in the comment box, because your attachment will encourage us to do better and best service to our lovely audience. Our mission is to empower our youth, so stay with us by your support. I am cordially welcoming you all, my dear and active participants. Today, we are presenting the webinar 107 or 107 on algebra cum calculus with two speakers from the Philippines, Isla Ermel Lacayanga and Tabama Rendator Bulendi from Philippines. So let's start our program with IGP mantra, feed your skills. Okay, so our first speaker rather is Isla Ermer Lacayanga. He is a master teacher and awarded as outstanding teacher municipal level. So we will introduce him with a short video. So let's watch.
Hello, good day. I am Elmer L. Isla, a Master Teacher 1 from the Philippines. I graduated the course Bachelor of Secondary Education, major in Mathematics in 2007, finished my master's degree in 2013, and my doctorate degree in 2017. As an educator, I am already teaching for almost 14 years now, and currently I am handling mathematics here in the Philippines. Throughout my teaching career, I have been coaching our mathematics team and was awarded as an outstanding teacher here in our municipality. I am pleased to be given an opportunity and I am looking forward to share what I know to all that will attend the webinar. Thank you and God bless.
Okay, so please give a warm welcome to our first speaker, Isla Elmer, sir. Hello, sir. Good evening.
Hello, ma'am. Rohamina. Good evening.
Yes, sir. Can you hear me?
Yes, ma'am. Loud and clear.
Okay. Yeah, we can hear you, sir. Thank you so much. So you can present your presentation or PowerPoint if you have.
Can you see my screen now, ma'am?
Yes, sir.
Will I start now, ma'am?
Sure, sir. You can start now. Okay, please welcome. Please give a warm welcome to our first speaker.
Magandang buhay to each and everyone who are present here today in this webinar. I hope and pray that you are all doing well and that you are all safe. But before we begin, I would like to extend my deepest thanks to all the people behind this webinar. I am truly grateful and honored to be selected as one of the speakers for today's session and to be able to share what I know to all. First, to the Lord Almighty for His grace and blessings, to the Institute of Global Professionals for providing us the platform to continuously share knowledge even during these pandemic times. To Dr. Nestor Nuesca, our regional supervisor in mathematics, for giving us this once-in-a-lifetime opportunity and confiding in us. To Dr. Ronaldo Pozon, our schools division superintendent of Tarlac Province, for the unending support. To Sir Augusto Ballesteros, our education program supervisor in mathematics, for believing in us always. To Dr. Nelia Andres, our school principal, for instilling confidence in us that we can do it. To our head teacher 6 in mathematics department, Dr. Alvin Reyes, for inspiring us to continuously do our best. To Sir Redentor Tabamo for the trust and confidence. To my math department family and BS Ans family for the inspiration, and to my family for the love and support. So I am Elmer L. Isla, a Master Teacher 1 of the Department of Education here in the Philippines. I have been teaching here for 14 years now, and I have been teaching the subject mathematics for the whole duration of my teaching career. I have been invited as one of the speakers before here in the Philippines in the different levels, but none more prestigious than the one that I'm doing right now. So that is why I'm very proud and pleased, and I'm looking forward to share the things that I know to you, and I hope that by the session's end, you will gain something from me and from my discussion. So for today's webinar, I am tasked to present the topic about quadratics. Quadratic equation, quadratic function, and inequalities to be exact. We will learn how to draw their graphs, solve for their solution set, and compute for the specific value or values of the variables that will make them tangent to a curve. So let us now proceed with the different terminologies that are associated with the topic. The very reason why students are having difficulties in math is because of their unfamiliarity with the different terms and concepts associated in a specific lesson. That is why it is important to teach them first the concept as well as the different terms, because in understanding something comes wisdom. So now, here are the different terminologies and concepts plus the formulas associated with the topic that I will discuss to you tonight. So the first terminology is the phrase tangent to the curve. In mathematics, a line is said to be tangent to the curve when a line and a curve happen to intersect at exactly one point. In the illustration, the point of intersection is indicated by the yellow dot. In this case, the line is said to be tangent to the curve. We can call the point of intersection as the point of tangency. Also, the phrase tangent to the curve is one of the more common phrases that you will encounter, especially in the pre-calculus. In actuality, my topic is directly related to the topic that will be discussed later after I have finished mine, and it will be presented by Sir Redentor Tabamo. Again, a line is said to be tangent to the curve when they meet at exactly one point. Next terminology is the parabola. The parabola is the graph of quadratic function. In this topic, we will only be dealing with parabolas that open upwards or downwards. A parabola opens upward or downward depending on the value of a, which is the numerical coefficient of the quadratic term. If the value of a is less than 0, the parabola will open downwards, while if a is greater than 0, or if it is positive, the parabola will open upwards. Also, in terms of the vertex of the parabola, it will be a minimum if the parabola opens upward, and it will be a maximum if it opens downward. Moreover, the vertex also divides the parabola into two similar parts. Next term is the solution set. It is the set containing all the solutions of an equation. In short, it refers to all the values of the variable that will make the equation be true, or in other words, these are the values of the variable that when substituted to the equation will make the equation balanced. The left side will be equal to the right side of the equation. The fourth term is the discriminant. The discriminant is a numerical value which can describe the nature of the roots of any quadratic equations or function. If the value of the discriminant is less than 0, or if it is negative, then the nature of the roots of the quadratic equation will be real and distinct, meaning the two values of the variable will be real and unequal. Now, if the discriminant value is equal to 0, then the roots of the quadratic equation will be real and equal. And lastly, if the value of the discriminant is less than 0, or if it is negative, then we will have imaginary roots. Now, to find the discriminant value, we will use the discriminant formula. And it is represented by the equation capital D is equal to b squared minus 4ac, where a, b, and c are the numerical coefficients of the given quadratic equation. A is the numerical coefficient of the quadratic term, b is the numerical coefficient of the linear term or the middle term, and c is the constant term. In addition, b squared minus 4ac in the formula is the discriminant part of the quadratic formula, which is also used to find the roots of any quadratic equation. And finally, we arrive at the formulas that we will be using for today's discussion. First off, I have already discussed earlier the discriminant formula, which can be used to find the discriminant value and consequently be used to describe the nature of the roots of quadratic equation. It is given by the capital letter D is equal to b squared minus 4ac. Next formula is the formula for the sum of the roots of quadratic functions or equations. It is given by the formula negative b over and a and b are the numerical coefficients of the quadratic term, and b and the linear term of any quadratic equation. The third formula is for the product product of the roots of quadratic equation. And it is given by the ratio C over A, where A and C are the numerical coefficients of the quadratic term, and C is the constant term respectively. Lastly, we have the square of a binomial formula, and it's given into two separate templates. So the first one is the sum of two terms raised to the power of 2, or A plus B squared. And to obtain its expanded form, we square the first term and then multiply the product of the first and the second term by 2 and square the last term. So we have the trinomial a squared plus 2ab plus b squared. So meanwhile, a minus b raised to the power of 2 when expanded will be equal to the square of the first term, which is a squared, twice the product of the first and the second term, which is equivalent to 2ab, plus the square of the last term, which is b squared. That is the pattern for the squaring of the binomial. So those are the different terminologies, concepts, and formulas that are associated with the topic for today. So that leaves us with that main topic now, which is all about the quadratics. Let us proceed. So we proceed with problem number 1. So we find the values of m for which the line y equals mx minus 9 is a tangent to the curve. So what do we do in here for the solution? So we have here the line of process for us to follow. So first, we will substitute the linear equation, which is given by the equation y equals mx minus 9, into the quadratic equation x squared equals 4y. Now, since the line is tangent to the curve, there is only one root. Hence, the discriminant must be 0. So always remember the discriminant formula and the nature of roots, so that you will be able to know if the discriminant must be greater than 0, equal to 0, or less than 0. So in this case, since we have only one root, the discriminant value must be equal to 0. So following our process, so this is the linear equation y equals mx minus 9. Then the quadratic equation x squared equals 4y. So the value of y is mx minus 9. By substitution, we will have the resulting equation 4 times the quantity of mx minus 9 equals x squared. So the y variable has been replaced by mx minus 9. Now by distribution, 4 times mx and 4 times negative 9, that will give us 4mx minus 36 equals x squared. Now, all you have to do is to join all the terms in one side of the equation, preferably the left side of the equation, so that we will have this standard form of the quadratic equation, x squared minus 4mx plus 36. So as you can see, if we do that, if I transpose x squared to the other side, that will give us negative x squared, or if we can simply transpose the other two terms in here. So we have x squared minus 4mx plus 36. Then nothing will be left on the left side of the equation. So this will become 0. Now by reflexive property, we can simply transpose the position of each other. So that is why we arrive at this quadratic equation, x squared minus 4mx plus 36. Now, after that, after determining the quadratic trinomial, we now proceed to the obtaining of the values of a, b, and c. Now remember, a can be obtained from the numerical coefficient of the quadratic term. In this case, it is x squared. So what is the number beside x squared? You cannot see any number, but in actuality, there is a number 1 there, and it is invisible. So we write 1 as the value of a. Next, for the value of b, it can be obtained from the x term, or the linear term, the middle term of the quadratic trinomial, and that will be equal to negative 4m. Next is the constant term, which is equivalent to 36. So these are now the values of a, b, and c. Now, having known these three values, we can now proceed with the solution using the discriminant formula. Since we have known that the line is tangent to the curve, therefore, we already know that b squared minus 4ac must be equal to 0. So by substitution of the values of a, b, and c, we arrive at this resulting equation. So b is negative 4m raised to the power of 2 minus 4 times the value of a, which is 1, times c, which is 36. Simplifying this, negative 4m raised to 2, we will have 16m squared. Then multiplying this 3, negative 4 times 1 times 36, that is negative 144. Now, as you can see, these two terms has a common factor, which is 16. So that means that the equation can be reduced by division of 16 to both sides of the equation. And that will leave us with the simplified form m squared minus 9 equals 0. Now, the left part of the equation is what we call the difference of two squares in mathematics, and they can be factored. So how do we factor m squared minus 9, or the difference of two squares? First, we prepare the two parentheses, just like so, and then get the square root of m squared, that is m, and then write each in each of the two parentheses, and then automatically we write plus or minus sign. That is automatic in this factoring technique, and then get the square root of 9, and that is positive, that is 3, and write each in the parentheses. Now, after getting the factored form, we will now apply the so-called ZFP. Now, what does ZFP mean? This is the zero factor property, wherein we equate the linear factors to 0 and solve the value for the unknown. So, having said that, m plus 3 is equal to 0, the first linear factor, and then m minus 3 is equal to 0. Now, by simply transposing these constants to the other side, we will arrive at the final answer, m is equal to negative 3, or m is equal to 3. These are the values of m that will make the line y equals mx minus 9 be tangent to the curve x squared equals 4y. So for those who are thinking what is the equation representing the line will be either represented by these two. So y equals negative 3x minus 9, or y equals 3x minus 9. So these are now this complete solution of the first problem. We now proceed with the second problem. So in here, we will find the value of k for which the line y equals x plus k is a tangent to the curve y squared equals 4x plus 8. So how do we find the solution for this? So we must first substitute y equals x plus k, the linear equation, into the quadratic equation. Y squared equals 4x plus 8. And the determinant is equal to 0. Why? Because we know that the line is tangent to the curve. When you encounter this phrase in the problem, you must already know, or you must automatically equate the determinant to 0. That is automatic. Okay? Now, proceeding to the solution, so we will substitute the value of y, which is x plus k, to the quadratic equation. Y squared equals 4x plus 8. So that will give us the resulting equation. X plus k raised to the power of 2 is equal to 4x plus 8. Now, by expansion, we will have this resulting equation. X squared plus 2xk plus k squared. Remember the formula that I have shown you earlier. So this is under the squaring of binomial. Square the first term, x times x, that is x squared. Then x times k is xk, then multiply it to the constant 2, hence 2xk. Then square the second term, so that is k squared. So that is the trinomial result. And then we transpose simultaneously the binomial from the right side to the left side to make them unified in the left side. So transposing, that becomes negative 4x and then negative 8. And then nothing is left at the right side, so hence the 0. Next, as you can see, as you can observe, in the resulting equation, there are two terms here that can be grouped together. Why? Because these two terms both have the x variable. So that means they can be grouped and that x can be factored out. So how is that? So x squared plus 2k minus 4 times x. So already the x variable was factored out here, and that is the result. Plus k squared minus 8. So this is now the quadratic trinomial for our given problem. So as you can see, it's not the regular format, but we can regard this as the quadratic trinomial, wherein we can get the values of a, b, and c. So how is that? Again, the value of a is obtained from the quadratic term. So there's no number there. That's automatic 1. There's an invisible 1. So for the value of b, it is obtained in the linear term, from the linear term. So the value is 2k minus 4. And lastly, for the value of c, we have k squared minus 8. Okay, so as you can see, it's not always automatic that the values of a, b, and c are integers. They can also be expressions, just like you can see in our problem. Okay, so the value of b and c are expressions, whereas a is an integer. Okay, so moving on. Having known these three values, we can now proceed with the solving of the determinant. Since y equals x plus k is tangent to the curve, okay, so plugging those a, b, and c values to the determinant formula, so b is 2k minus 4 raised to the power of 2 minus 4 times the value of a, which is 1. Then k squared minus 8 is the value of c. So let us expand this. So this is a square of a binomial. So square the first term, that is 4k squared. Now, 2 times the product of the first term and the second term. So 2 times 2k, that's 4k, times negative 4, that's negative 16k. Then square of the last term, that is positive 16. And then multiply this 3. Negative 4 times 1 is negative 4 times 4 times k squared, that's negative 4k squared. Negative 4 times 1 times negative 8, that is equivalent to positive 32 equals 0. Okay, now looking at this resulting equation, we can see that we have two terms that are k squared. So we can combine them. And as you can see, they are additive inverses of each other. When we combine additive inverses, that is always equal to 0. So we might as well cancel these two. So for the k term, it is only 1, so we might as well rewrite it, negative 16k. And then for the constant, we have 16 and 32. We can combine these two. So we have positive 48 is equal to 0. Now solving further for this, to solve for the value of k, we can transpose 48 to the other side. So 16k is equal to negative 48. From positive, it became negative. And then dividing both sides by negative 16, so we have the k value is equal to positive 3. So the k value is 3. So these are now the final part of the solution. So that means that the line will be tangent to the curve y squared equals 4x plus 8 when k is equal to 3. The equation of the line is y equals x plus 3 by substituting the value of k to the given equation right here. Okay, so that finishes our solution for the second problem. Let's proceed with the third one. Find the value of a and b for which the solution set of the quadratic inequality x squared plus ax is greater than b is the union of the set of x such that x is greater than 2 and set of x such that x is less than negative 4. So what is the thought process for the solution? So we substitute the roots into the equation and compare the coefficients of x and the constant. So the given inequality is x squared plus ax is greater than b. So first thing to do is to transpose b to the other side so that all terms will be at the left side of the inequality. So there you go. So from positive b, it becomes negative b, and then nothing is left at the right side. So we replace with 0. Okay. Now, next, since x is equal to -4 and x equals 2 are roots of the equation. Okay, let's hold on for a minute. So where did we obtain x equals -4 and x equals 2? So looking at the problem, it's not stated there. But alas, it is hidden. It's a hidden given. So these two are obtained from the solution set. So we can regard this as equations. So we can regard as x is equal to 2, replace the inequality symbol to equal sign, and then for the second one as well, we replace it with the equal sign, this one, -4. Hence, the two roots are obtained. X equals -4 and x equals 2. So that is the temporary value for the roots. Okay, now, x plus 4 times x minus 2 is greater than 0. So as you can see, this is a factored form. Factored form. Now, how did we obtain this factored form? Actually, we use the reverse process of the ZFP, as I've discussed earlier. So what's the meaning of ZFP once again? That is zero factor property, wherein we equated the linear factors to 0. So now, from here, we reverse the process. We transpose it back together with the term, the variable x. So that means we have x minus 2 equals 0. Then same thing here, x, it becomes +4 equals 0. So hence we obtained the two linear factors for this statement. So that is where we obtained those two. Next, we expand this through the FOIL method in mathematics. FOIL. This stands for the first term, outer term, inner term, and last term. So first term, or F, are these two. So we multiply them. X times x, that's x squared. Then for the outer terms, these are the two outer terms. So this is our O. X times -2, that is -2x. And then for the inner terms, these are the two inner terms. So that is I. So 4 times x, that's +4x. And then for the last terms, these are the two last terms. 4 times -2 is -8. It's greater than 0. And then as you can see, the two middle terms are like terms. So we can combine them. So x squared, right? -2x plus 4x, that is +2x minus 8 is greater than 0. So this is now our quadratic inequality. Okay, there you go. Now, a is equal to 2 and b is equal to 8 based on the obtained quadratic inequality. So how did we obtain these two values? A is equal to 2, b is equal to 8. In actuality, we use the given. X squared plus ax plus b. So x squared plus ax is greater than b. Okay? So a is beside the linear term. So looking at the formed quadratic equation, the number or the numerical value, numerical coefficient is 2. Hence the value of a. And for the b, we can transpose this back. So that will become +8. Hence the value of b, which is 8. Okay, so there you go. That is now the solution. Let me go back. So these are now the solution for the problem. So these are the values of a and b for which the solution set of the quadratic inequality x squared plus ax is greater than b. Next problem. We find the range of values of x for which x times the quantity of 2x plus 5 is greater than 12. So for the solution, we bring 12 from the right-hand side of the inequality to the left-hand side, expand and factorize the inequality, and solve by sketching a quadratic graph. So let us do all those. So this is now the given. And then what happened here? So x is distributed to the binomial. So x times 2x, that is 2x squared. X times 5, that is 5x. And then we transpose 12 to the other side, that becomes -12. And then look, we have created the quadratic inequality. So that means we will now try to factor this out. Now, I will try to introduce to you the so-called triangle technique in factoring quadratic trinomials, just like this. Okay, so this triangle technique is a technique that I have learned many years ago when I was still a student, of Sir Dennis Santillan. So I have learned this technique from him. So shout out, sir, thank you. And I have really remembered this technique because I saw that this is really effective in getting the um, factored form of this trinomial. So thank you, sir. And I am also applying this learning now to my classes, to my students. Okay. So what to do? What's this triangle technique? So first we prepare the two parentheses, and then we make an underline that will represent the division sign or the fraction bar. And then after that, we get the value of a, which is 2. What to do? We will write this 3 times. Here, here, and then here. Then after that, we get the factors of x squared. That is simply x and x. And we write those two in each of the two parentheses. Now, next, here comes the sign at the middle. So how can we determine the sign at the middle? So there are 3 combinations or scenarios that are possible. It's either positive for the first one, positive for the second one. It's either negative, negative, or it's either positive or negative, or vice versa, negative, positive. So which one of these 3 will be the one to be written at the middle? So how do we determine that? In actuality, it is very easy. All you have to do is to look for the last sign. So minus sign at the last term or the constant term means that we will write an automatic plus minus here. So that's automatic. When you see a minus sign at the constant term, it is an automatic plus minus. So remember that. Now, we now proceed with the last part, which is here. So these are numbers. And to determine these numbers, we will now employ the pyramid part. Hence the name. Actually, triangle is what I have written. It's actually pyramid. Actually, I have just invented this so that I can name this technique. I can identify this technique. Okay, so we will write at the top of the pyramid a number. And what is that number? It is the constant. Always the constant. Or actually, sorry, the trinomial, let me erase this. The trinomial is in the form where a is not equal to 1. So in this case, we will multiply the value of c and the value of a. And that is equivalent to 24. So this will be written at the top. Okay, now directly beneath it will be a sign, plus or minus. And what is the specific sign? It is the sign found at the constant term, negative sign. So whatever sign is in here, it will be written below here. Okay, now equals the number or the numerical coefficient at the middle, which is 5. There. So now the pyramid setup is complete. Now here comes now the thinking part. We now think of 2 numbers that when subtracted is equal to 5 and when multiplied is equal to 24. If you are thinking 8 and 3, you are definitely correct. So 8 minus 3 is equal to 5 and 8 times 3 is 24. So these 2 numbers are what we are looking for. So this will now be written at the last spot. Okay, now, but here's the catch. Since we have 2 unlike signs, we cannot write immediately the 2 numbers as we like them to be positioned. What do I mean? The position of the numbers are specific. So how to determine the specific position? We consider the greater number 8. The greater number must always follow the middle sign. So the middle sign is positive. Hence, 8 must be written here. This cannot be interchanged. Remember that. Okay? So because when we write 8 here, it will become negative. No, it must be positive. And then the remaining number will be written here. Okay, so the content of the two parentheses is now complete. All you have to do now is to get the common factor of any of the two parentheses. So the first parenthesis is the common factor, which is 2. Then factoring that out, that will leave us with x plus 4 inside the first parenthesis. For the second parenthesis, it is already in its prime form, meaning it has no common factor. So we simply rewrite all over 2. So 2 divided by 2, this will now cancel each other out. So now we have now obtained the factored form of the given trinomial. Now, as you can see, this may be your first time to encounter this. So maybe you're thinking that it's too difficult. There are too many steps. But I tell you, if you get the hang of this technique, you will be enjoying this and applying this more and more when it comes to factoring quadratic trinomial. So my suggestion is to try to apply this more and more, and eventually you will come to love this pyramid technique. Okay, now going back to the solution. So we have now obtained the factored form. 2x minus 3 times x plus 4 is greater than 0. Okay, now we have these values of the x, which is less than 4, or x is greater than 1 and 1/2. So we simply applied the zero factor property in this, wherein 2x minus 3 is equal to 0, x is 2x is equal to 3, then divide both sides by 2, x is equal to 3 over 2, or in our final answer, that's 1 and 1/2. Also with x equals x minus 4 is x plus 4 rather is equal to 0, the transposition, x is negative 4. Now, the question here is, why is it that this inequality symbol is greater than and this one is less than? So what happened here? So we will now try to clear that up. So in here, using the number line, so this is negative 4 and this is 3 over 2. Now, we can see that the solution set is composed of integers that are less than negative 4 and integers that are greater than 3 over 2. Now, what happened? Now, remember, when we plotted these two values of x in the number line, we have indirectly created regions. So, by having said that, there are three regions that was created by doing so. So this is region 1, this is region 2, and this is region 3. Now, from each region, we will get some test points. So these test points are just simply integers that belong to the region. So say for instance, in this, we know that since this negative 4, negative 5 belongs here. So we can use this as our test point. Also in here, this is between negative 4 and 3 over 2. I suggest that you pick the most convenient number, and one of the most convenient number to use is 0. So 0 can be used as the test point. And from here, 3 over 2, that's 1 and 1/2. So the next integer is 2. So we can use 2 as the test point. Now, what to do with these test points? All you have to do is to substitute each of this into the given inequality. And if the inequality statement yields a true statement, then the region will be considered as one of the solution set for the given inequality. And if it is false, then it's not included. The region and the integers belonging to it will not be considered in the solution set. Now, we will try to discuss this further in the next examples. I think that's example number 5. But I will just be showing you a quick substitution process. So negative 5. So this becomes negative 5. Then this becomes negative 5. So 2 times negative 5 is negative 10 plus 5. That's negative 2 times negative 5 is negative 5 times plus 5 is negative 5 times negative 5. That is equivalent to 25. Now, is 25 greater than 12? True or false? Yes, this is a true statement. Hence, we have a true statement for this region. Hence, these numbers from negative 4 onwards will be included in the set. Hence, the arrow, as you can see. But as you can see at the uh, directly above negative 4, there's a hollow circle. So what does this mean? This means that negative 4 will not be included in the solution. But if negative 4 is included, this will be a closed circle. It is shaded. Okay. Now for 0, so this is 0 times 2x plus 5. This is equivalent to 0 is greater than 12. Is this true or false? This is false. Hence, we will not include the integers belonging to region 2. Now, for the final region, which is 2, multiplying this 2 times 2, 4 plus 5, that's 9 times 2, this is 18. So we have the final statement, 18 is greater than 12. Is that true or false? That is true. Hence, we include the integers in region 3, except 3 over 2. Okay, because it's represented by the hollow circle. So again, we will discuss this more in depth in the next example. So let's leave it for now. So find the value of constant k for which the equation 4x squared plus k squared plus 1 is equal to 4 times k minus 3x has equal roots. So we let the right-hand side of the equation be 0 and solve for k. So this now the given. So what shall we do? So what happened here? It's simple. This term was transposed to the other side. And this is that term. From positive 4, it became negative 4. Okay. Now, as you can see, we have now obtained the quadratic trinomial, wherein we can derive the values of A, B, and C. So what are the values of A, B, and C here? So the value of A is 4. The value of B is negative 4 times k minus 3. And the value of C is k squared plus 1. So plugging that into the discriminant formula, we have this. Negative 4 times k minus 3 squared minus 4 times k squared plus 1. Okay, now simplifying this. So what happened? So negative 4 raised to the power of 2, that's positive 16. And then k minus 3 raised to the power of 2 is this one. Negative 4 times 4 is negative 16 times k squared plus 1. And then expanding, 16 times, this is the square of a binomial once again. So k squared minus 6k plus 9. And then distribute this, negative 16k squared minus 16. Next, we substitute 16 to the trinomial. We have 16k squared minus 96k plus 144 minus 16k squared minus 16. Now, looking at this resulting equation, we have two k squared terms, and they are additive inverses of each other. It's equivalent to 0 when added, so we might as well cancel. Then k term is only 1, so rewrite. Then the constant term is 2, so combine. This is equivalent to, I think, 128, if I'm not mistaken. Okay, there you go. So 96k minus 128 equals 0. So it's already transposed to the other side. Let me erase that. Okay, now moving on. So dividing both sides by 96, we now have the k value, which is equal to 1 and 1/3, or we can simply say this is equivalent to 3 over 4. Sorry, it's 4 over 3. It's 4 over 3. So 1 times 3 plus 1 is 4 over 3. Okay. So there you go. That's now the final answer for this problem. Okay. Next, we find the range of values of x for which x squared plus 3x minus 4 is greater than 5x minus 1. So for the solution process, rearrange the inequalities such that the right-hand side is equal to 0. And then we factorize the quadratic equation and use number line to find the range of values of x. So this is now the given. So transpose the binomial to the other side. So that becomes negative 5x and then positive 1. And then nothing is left at the right side, so 0. And then, as you can see, we have x terms here. This can be combined as well as two constant terms. This can be combined as well. So we have x squared, 3x minus 5x, that's negative 2x. And then negative 4 plus 1, that's negative 3. Again, we factor this out by our pyramid technique. Pyramid technique. Okay, now since the quadratic trinomial is of the form where a is equal to 1, this is much easier than the one that I have presented earlier. So in here, we simply prepare the two parentheses. This time, there's no underline. Okay, so that's the difference. Now, get the factors of x squared, that's x and x, write them in each of the two parentheses. Now, the middle signs will be obtained or determined by looking at the last sign. So that's negative. Again, automatic positive, negative, if it is negative. And then, for the last two slots, we now employ the pyramid part. So in here, the number will now be the constant only, which is 3. So before, we multiply the constant to the value of a. So since a is non-existent, or a is existent but it is 1, so it's waste of time if you multiply 3 by 1, so it's still 3. So we might as well copy 3. And then copy the last sign, which is negative, equals the middle number, which is 2. Now think of two numbers that when subtracted is 2, when multiplied is 3. I think this is an easy one. So the two numbers are 3 and 1. 3 minus 1 is 2, 3 times 1 is 3. Now, where to put the larger number, 3? Now, if you answered negative, you are correct. Why? Because as I've said earlier, the larger number will always follow the middle sign. And then 1 will be here. And there you go. We have now obtained the factored form of the quadratic trinomial. Okay, going back to the solution, x plus 1 times x minus 3. And then using once again the number line. So as I've said earlier, we will try to discuss these test points more in depth. So here's now that example that I'm talking about earlier. So we have three regions, as I've said earlier, region 1, region 2, and region 3. And we will get some test points. So from region 1, what is the most convenient test point? I think it's negative 2. So we can use negative 2 here. Next, for region 2, what's the most convenient one? I think it is 0. So if you have the chance to use 0 as the test point, do it. And then maybe 5. 5, since multiplying by 5 is much easier than any other number, except 1 and 0 and 10. Okay, now, what to do? We will substitute these three test points to the given equation. Let me go back. What is the given equation? X squared plus 3x minus 4. Okay, let me write that. X squared plus 3x, x squared plus 3x minus 4. Okay. So I think I have not written the quadratic inequality, so it's not convenient to do this once again. But when you substitute this will be the result: positive, negative, positive. So since the inequality calls for that this statement must be greater than 0, so we will just get the regions that will yield the positive value. Hence, for region 1, when we substitute those test values, we have plus sign here. So it's positive, this is negative, and this is positive. So that means that the solution set will be obtained from this solution, from this region rather. So x is less than negative 1 here, and then x is greater than 3. So again, why did we get the positive regions? Because in the statement, we want the inequality to be greater than 0. And when we say greater than 0, those are numbers that are positive. So we disregard the negative value. So that is the rationale behind this thinking. Okay, next. Find the range of values of c given that for all values of x, x squared minus 5x plus c is greater than 0. So again, we rearrange the inequalities such that the right-hand side is equal to 0. Identify the nature of roots such that the function is greater than 0. So here's the given. So we rearrange. So transpose 2 to the other side. That becomes negative 2. And then for x squared minus 5x plus c minus 2 to be always positive, we must have the discriminant to be greater than 0. Okay, now negative 5 squared minus 4 times 1 times c minus 2 is less than 0. So where did we get this? Again, these are the values of a, b, and c, and it is obtained right here. Okay, there you go. This is b, this is a, then this is c. Okay, so there you go. Now simplifying, 25 minus 4c plus 8 is less than 0. 33 minus 4c is greater than 0, and we have 4c is greater than 33. Hence, we have the value of c, which is 8.25. Now, next, we find the range of values of k for which the curve y equals 16 over x intersects the straight line y equals k minus x at two distinct points. So to intersect at two distinct points, then the equation must have two distinct solutions. So what does that mean? So the discriminant value must be greater than 0. So remember again the nature of the roots of the quadratic equation. So if the discriminant is greater than 0, then we have two distinct solutions. So this is now the given. Then what happened here? So we simply cross-multiplied. Okay, so x times k, that's kx. So let me write here. 16 is equal to k times x, that's kx, minus x squared. And then we transpose them to the other side of the equation. So that will give us this quadratic trinomial, x squared minus kx plus 16. Now, next, we have the discriminant is equal to b squared minus 4ac. So k minus k squared, the value of b, minus 4 times the value of a, which is 1, times 16, which is c. Simplifying, we get k squared is greater than 64. Now, getting the square root of both sides, square root of this and square root of this, we get the value of 8 and negative 8. So k is greater than 8 or k is less than negative 8. Now, again, where these two inequality symbols come from? Again, through the use of the number line, the region technique. Okay, wherein we get here negative 8 and then 8 and then get the test points. So you by using this, you will determine that the solution set will be from here and then another will be from here. So the middle integers will not be included in the solution set. Okay, so what are the test points? By the way, so in here, we may use negative 10. In here, of course, we use 0. And here, we use 10. So these are the convenient integers to use for the given problem. And you will find out that the solution set will belong in the first region and the third region. Okay, next. Find the solution set of the quadratic inequality. Number 1, x squared minus 8x plus 12 is greater than 0. And number 2, x squared minus 8x is less than 0. Hence, find the solution set of the inequality of the absolute value of x squared minus 8x plus 6 is less than 6. Okay, so factorize the two equations. Then solve the inequality using the values found in 1 and 2. So again, by factoring, again, we will use the pyramid technique as I've shown earlier. So I will not repeat that anymore. So in using that technique, we will arrive at the factored form x minus 2 times x minus 6 is greater than 0. Hence, by using again the region and the test points, we will arrive or we will determine that the solutions will be obtained in this region and this region. So the middle region is once again not included in the solution. Now, doing that again to the second statement, x squared minus 8x. So, as you can see, the two terms has a common factor, which is x. So, factor that out, x times x minus 8. Now, using the zero factor property, so the first factor is x equals 0, then x minus 8 equals 0. The second value of x is equal to 8. So we have a 0 and 8 in our number line. Now, again, the test point region. Now, this time, as you can see, if we use the test point, so we can use here 1, we can, this negative 1, we can use 1 here, and then we can use 10 here. So these are the convenient numbers in its region. And when you use these test points in and solve for the true-false statement, you will see that the second region will have the true statement, and region 1 and 2 will have the false statement. So this time, the middle region will have the true statement. Now, moving on. We have now solved the 1 and 2 inequalities. Now, it's time to solve for the last term. Okay, so these are now the solutions earlier. Okay, so this is now an absolute value. Now, for any absolute value, it has two values always. Number one, it's positive, and number 2, it's negative. So remember this in our solution. So because we will apply this. Okay, so what do I mean? So here you go. So the first one is the positive part. X squared minus 8x plus 6 is less than 6. Positive part. And then the negative part, negative quantity x squared minus 8x plus 6 is less than 6. So positive and negative. So in a quadratic, in an absolute value expression, this is always the case or the solution that we must do. Okay, now simultaneously solving, so x squared minus 8x plus 6 minus 6. So what happened? We transpose 6 to the other side as well as here. And then as well as we distributed the negative sign to the trinomial. Hence, negative x squared plus 8x minus 6. Next line, we can see that 6 and negative 6 are additive inverses. So we cancel. That leaves us with x squared minus 8x is less than 0. Here, we can combine these two. So negative 6 and negative 6, this becomes negative 12. And then, this has a common factor, this binomial. So factor that out, x times x minus 8. And then here, what happened? So as you can see, the quadratic term became negative. So we simply multiplied negative 1 to both sides of the equation to make the quadratic term positive because it is the proper form of the quadratic trinomial. The quadratic term must be positive. Okay. Now, after that, we can now solve for the solution set. Okay. Again, to solve for the solution set of this, use the test points, wherein the first value is x equals 0, and then x is equal to 8. So this 2 will divide the number line into 3 regions. And here, this must be factored using the pyramid technique. So using the factored form, we will arrive at x minus 2, then x minus 6. Okay, hence the two values 2 and 6. And then again, using the test points and the regions, we can determine that the solution set will be found at x is less than 2 or x is greater than 6. Okay. Now, looking at the number line, combining the information obtained from 1 and 2 and the last inequality, the absolute value inequality. Okay, so here is the solution for the first part, this one. Okay, so x is less than 2. Okay, a hollow circle is found at the directly above 2, which means that 2 is not included in the solution. Also, we have x is greater than 6. There you go. So 6 is not also included, but any number greater than 6 will be included in the solution. Next, for this one, we have 0 is less than x is less than 8. So actually, in actuality, as you can observe, the solution for the absolute value is equal to the solution set for that first two equation. Okay, so we can combine them, those three informations. Now, for this one, so 0 is less than x, but so x is greater than 0 but less than 8. So that means that the x values will be found between 0 and 8, excluding 0 and 8. Now, having said that, the solution set of the three given inequality is the one that is found at the overlapping portion of the two graphs. So there you go. So the two graphs overlap at this portion. This means that this portion and this portion is the solution of the three inequalities. Okay, so there are situations like that when you are comparing the solution set of inequalities, you will be getting the overlapping portion of the graph, and that will lead you to the solution of the whole set of inequalities. Okay, so there you go. So here's now the representation. X is greater than 0 but less than 2, representing this red part. And then x is greater than 6 but less than 8, so representing this red part. So the solution set is any number between 6 and 8 and 0 and 2. Now, find the range of values of k for which the line x plus 3y equals k and the curve y squared is equal to 2x plus 3 do not intersect. So substitute the linear equation into the quadratic equation. Discriminant is less than 0. So again, we employ the process that we have already made from the previous example. Substitute y value to the quadratic equation. So we have this resulting equation. K minus x over 3 raised to 2 equals 2x plus 3. And then, what happened? So 3 raised to 3 is 9. K minus x raised to 2 is k minus x squared equals to x plus 3. Now, expanding and then cross-multiplying, so we have k squared minus 2kx plus x squared equals 18x plus 27. And then transposing the binomial to the other side to make all the terms belong to the left side. So here's this resulting equation. And then let us see. We can see that we can group these two. Okay, so both have x variable. So doing that, factoring that out, x squared plus x minus 2k plus 18 plus k squared minus 27. And from here, we can know the values of a, b, and c. So the value of a is 1, value of b is negative 2k plus 18, and value of c is k squared minus 27. Now, using those information in the determinant b squared minus 4ac is less than 0. Since the line and the curve do not intersect, that means that there's no solution, or imaginary, the roots are imaginary. So hence less than 0. Now, plugging those a, b, and c values, we will have this. Then simplifying 4k squared plus 72k plus 324 minus 4k squared plus 108. Okay? Now, k squared and negative 4k squared, this will cancel out, additive inverses. 72k plus 432. Okay, add the two constants. And then transpose 432 to the other side and then divide both sides by 72. We have k is less than negative 6. Okay, so this is the k value. So the line is x plus 3y is equal to negative, less than 6. It's either, we can say that it is 7, 8, and so forth and so on. Okay, so it's not 6, negative 6, since the statement is less than negative 6. Let me erase that. Okay, so there you go. Next, the roots of the quadratic equation 2x squared minus 4x plus 3 is equal to 0 are alpha and beta. Find the quadratic equation whose roots are alpha squared plus 2 and beta squared plus 2. Now, for this solution, again, since we are now under the sum of the roots, we will now use the formulas that I have presented earlier at the first part of our discussion. The sum of the roots is negative b over a. The value of b is negative 4, and the value of a is 2. So, negative 4 over 2 is equivalent to positive 2. So, this is now alpha plus beta, the sum of the two roots. Next, for the product of roots, we have c over a. The value of c is 3, and the value of a is 2. So substituting, we have 3 over 2, and this is our alpha beta, or alpha times beta, the product of the roots. Now, for the sum of the new roots, these are now the new roots. A squared plus 2 and b plus 2. I think this squared is omitted here. Okay, let me just write a squared plus 2 plus b squared plus 2. Now, as you can see, 2 here are constant, so we can combine them. Hence, we have 4 here. A squared plus b squared plus 4. Now, here's the big hint here in solving this problem. So we have a squared plus b squared is equal to a plus b squared minus 2, alpha, I should say. Alpha squared plus beta squared is equal to the quantity of alpha plus beta squared minus 2 alpha beta. Now, when I first encountered this, I am wondering, where does this equation come from? So, by further analyzing, I discovered that since when we expand this, we have alpha square by square of binomials 2 alpha beta and plus beta square minus 2 alpha beta. Now, looking at the result, we can see that 2 alpha beta and negative 2 alpha beta can be cancelled out, leaving us with alpha squared plus beta squared, which is the same as the original expression. So that means that a squared plus b squared can also be written as this one. So that will be the biggest hint for this problem, for the solving of this problem. Now, having known that, okay, so what happened? So alpha plus beta square is minus 2 alpha beta. So what happened? So from the previous equation, alpha square plus beta square. So in the next line, we simply substituted this expression into the equation. So alpha squared plus beta squared is actually this value. Okay, now, having known that, again, previously we have learned that alpha plus beta is equal to the value of 2. Also, we have learned that alpha times beta previously has the value of 3 over 2. So we can now substitute those values into the statement. Hence, 2 squared minus 2 times 3 over 2 plus 4, leaving us with the simplified form of 4 minus 3 plus 4, and that is equivalent to the value of 5, which is the sum of the roots. Next, we now proceed with the product of the roots. Again, alpha plus 2 times beta plus 2. So simplifying this, we have alpha square beta square plus 2 alpha square plus 2 beta square plus 4. Okay, now, as you can see, we can group these two. Okay, so factoring out 2, we will arrive at this. Alpha square beta square plus 2 times alpha square plus beta square plus 4. Now, we can also extract or simplify this as this one, alpha beta raised to the power of 2. It's still equivalent to the previous term. Plus 2 alpha square plus beta square plus 4. So alpha beta is 3 over 2 raised to the power of 2 plus 2 times 1. Again, where does 1 come from? So let me have this solution. Okay, so again, we have already learned that alpha plus beta in the previous example is equivalent to, let me check, 2. Oops. Okay, alpha plus beta is equal to 2 squared, and then this minus 2 alpha beta is 3 over 2. Okay, in our previous solution. So 2 squared is 4 minus 3. It is equivalent to 1. Hence, a squared plus b squared is equivalent to 1. Okay, so there you go. That's why we have 1 there. So 2 times 1 plus 4. And then simplifying this, we get 8 and 1/4, the product of the roots. Now, for the final solution, we have now known the sum of the roots and the product of the roots. We can now proceed with the construction of the equation. So this is the template. X squared minus sum of the roots, x plus product of the roots. By substitution, x squared minus 5x plus 8 and 1/4. We simply plug this information in the template. Also, we can also simplify this by multiplying, we can also multiply 4 to the whole equation. Okay, where's my, yeah. We can multiply 4 to the whole equation to eliminate the denominator. So that will give us 4x squared minus 20x plus 9 is equal to 0. Okay, so this is the other form if we want to eliminate the denominator. Okay, next. I believe this is my last example. So given that the roots of 3x squared minus 2x plus 1 is equal to 0 are alpha and beta, find the quadratic equation whose roots are alpha plus 2 beta and 2 alpha plus beta. So again, we get the sum of the roots, negative b over a, then getting the values of a and b, and then substituting, we arrive at the sum of the roots, 2 over 3. For the product of the roots, we have c over a, substituting the values of a and c, that is 1/3. So that's alpha times beta. Now for the sum of the new roots, we have alpha plus 2 beta plus 2 alpha plus beta. So these are the two new roots. Okay, now we can simplify this as 3 alpha plus 3 beta. We can combine since they are like terms. Now, we can also proceed with the factoring out of 3 since that is their common factor. And then, we have the value of alpha plus beta, which we have solved earlier, 2/3. So, by substitution, 3 times 2/3, we have the sum of the new roots, which is equal to 2. Next, for the product of the new roots, alpha plus 2 beta times 2 alpha plus beta, expanding that, we will have 2 alpha square plus 5 alpha beta plus 2 beta square. And then, what happened here? We grouped these two terms since they have the two similar, they have the common factor of 2. And then factoring that out, 2 times alpha square plus beta square plus 5 alpha beta. Now again, we use this convenient hint wherein a square, alpha square plus beta square is equal to this expression. Okay? Now, moving on, we have alpha square plus beta square is equal to the expression, this one, plus 5 alpha beta. And then, by substitution of the sum and product that we have first obtained, 2/3 and 1/3, in the expression, we arrive at this. So 2 times 2/3 squared minus 2 times 1/3 plus 5 times 1/3. So simplifying all those, we arrive at 1 and 2 over 9, which is the product of the roots. Okay? Now, we have the sum and the product of the roots. All you have to do now is to construct the given quadratic equation by plugging this information in the template. Okay, so we have now x squared minus 2x plus 1 and 2 over 9, or simply 9x squared minus 18x plus 11 if we want to eliminate the denominator by multiplying 9 to the whole equation. So 9 times x squared is 9x squared, 9 times negative 2x is negative 18x, and then 9 times 1 and 2 over 9 is 11. Okay, so there you go. That ends my topic about the quadratics. So I hope that you have learned something from me despite the limited time. And I hope that I will be meeting you once again. So thank you, and God bless everyone.
Okay, what a wonderful presentation and interesting topics you have shared to us, sir. Thanks for enlightening us with your pearls of wisdom and techniques in solving problems related to quadratic inequalities. No doubt our viewers will be benefited today from the techniques you have shared. Thank you so much, sir.
You're welcome, ma'am.
Okay, so it's time to move on to our next speaker, none other than Tabamo Redentor Bulanadi. But before that, I want to remind you all to please support us by sharing this webinar, tag your friends, or mention their names in the comment box. We will give the e-certificate link in the comment box, and if you face any problem downloading your or collecting your e-certificates, please visit directly our website www.eduigp.com. And after that, after collecting your e-certificate, please don't forget to celebrate with IGP by check-in. Okay, so our next speaker is a head teacher 3 and awarded as outstanding teacher municipal level. So I'd like to introduce him with a short video. So let's watch.
Hello, good day. I am Redentor B. Tabamo, Head Teacher 3, OIC, Assistant School Principal from the Philippines. I graduated the course of Bachelor of Secondary Education, major in Mathematics, in 1992, and at the same time, my Master of Arts in Teaching Mathematics in the year 1998. As per my teaching experience, I have been a teacher in the Philippines as well as in Brunei Darussalam. Abroad, I taught for 8 years and served as a teacher in upper primary and lecturer in tuition center, teaching additional mathematics and Gen Maths. I have also served as a coach of our mathematics teams here in our country, where we qualified for the regional level. I was also awarded as outstanding teacher of our municipality. I am pleased to be given an opportunity and looking forward to share what I know in the field of mathematics to everyone. Thank you very much and God bless.
Okay. Thank you so much, sir. So please give a warm welcome to our active speaker, Sir Tabamo Redentor Bulanadi. Sir, good evening.
Yes, good evening, ma'am.
Okay, sir.
Uh, Mabuhay, Maya Pabengi,
Mabuhay,
and
sir.
it's nice to share what we have, and it is our pleasure to be one of the speaker for tonight webinar. So, can you see now my presentation, ma'am?
Not yet, sir. Oh, okay, coming. Yes, sir. Okay.
So, again, I'm Mr. Redentor Tabamo from the Philippines. I've been in the field of teaching for almost 30 years. I started teaching in 1993, and from 2005 to 2013, I was given an opportunity to teach in Brunei Darussalam, wherein I handled the upper primary mathematics and teaching general math and additional math. So the topic that I'm going to discuss for tonight is intended for grade 10 and grade 11 of the K to 12 curriculum here in the Philippines. For those who are outside in the Philippines, are these topics intended for the O-level examining, taking the O-level exam. I extracted questions from different topics in the pre-calculus subjects such as series, sequences, polynomials, and circles. But before that, let me acknowledge first the people behind this seminar. Well, of course, I want to say thank you to the Institute of Global Professionals, to our regional supervisor in mathematics for giving us the chance to be one of the presenter of this international webinar, Dr. Nestor Pinwesca, to the head of the SDO Tarlac Province, Dr. Ronaldo Poson, our school superintendent in the division of Tarlac Province, and also the superintendent of division of Pampanga for pushing me always in my limit, Dr. Edgar Domingo, to our education supervisor, Augusto L. Ballesteros, in our EPSBR in mathematics for the trust as well as giving us the confidence. Our principal served also as a mother, not only as a principal, Dr. Nelly Andres, for the encouragement and trust that she always given to us. To my math department in junior high school, headed by Dr. Alvin P. Reyes, of course, and to my senior high school family where I serve as the assistant school principal, one of the biggest public school here in the Philippines, BS Aquino National High School. So the topic that I'm going to discuss again are extracted from pre-calculus subject, but before that, I just want to present to you some of the important formulas that are useful in dealing with the topic as we go along with our discussion. So the first one is all about arithmetic sequence. Arithmetic sequence in the form of a sub n equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the last term, a sub 1 is the first term, n stands as the number of terms, and d stands as the common difference. Under geometric sequence, so we have a sub n equal a sub 1, multiply that by r raised to n minus 1, where a sub n again as the last term, a sub 1 is the first term, r refer to the common ratio, and n stands as the number of term. For the sum of the geometric sequence, we have a sub n equal to a sub 1 times the quantity of r raised to n minus 1 all over r raised to n. For the equation of circle in the standard form, if the center is at point A and B, or some other book they are using H and K. So it's okay, you can use any variables, they have the same meaning. So for the equation of the circle in the standard form, we have the quantity of x minus a squared plus the quantity of y minus b squared equal to r squared, where the center is at point A and B, and radius or simply r serve as the radius. If the equation of the circle or the center of the circle is at the point of origin, that means the center is at point 0, 0. Then the standard form of an equation of a circle, we have x squared plus y squared equal to r squared. We have also the distance between 2 points. equal to the square root of the quantity x sub 1 minus x sub 2 squared plus the quantity of y sub 1 minus y sub 2 squared. Midpoint formula. In terms of x, we have x sub 1 plus x sub 2 over 2. In terms of y sub 1 plus y sub 2 all over 2. The slope or the gradient between 2 points, we have m stands as the slope or the gradient, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And the standard form of the equation of a circle, ax plus by equal to c, where a, b, and y are any real numbers. So let's have the first problem. So the first problem is under sequences. If the three arithmetic means are inserted between 11 and 39, find the third term of the sequence. Now, so since the first term and the last term is given, you were asked to find the second term, the second arithmetic mean. So we have now the general formula. We have a sub n equal to a sub 1 plus the quantity of n minus 1 times d. Now, based on the given problem, the last term is given. We just simply substituted the value in the given formula. Now, so to visualize the problem, so let's have first this one. The last term is given, the first term is given. So you were asked to find the second arithmetic mean. By substitution, let us now substitute a sub n equal to 39, or simply substitute the given formula a sub 5, because as you can see in the diagram given or illustration, we have 5 terms. A sub 5 equal to a sub 1 plus 5 minus 1 times d. Now substituting that in the given formula, last term is 39. A sub 1 is the first term. 5 minus 1 is 4, multiply that by d, equal to 4d. So, in order for you to get the second term or the second arithmetic mean, we need to find first the d, or simply the common difference. The common difference is simply the constant to be added in order for you to get the next term. Now, we have the equation 39 equals to 11 plus 4d. By applying the addition property of equality, so the resulting equation, sorry, there's a typo error with that. So it should be 39 minus 11, it should be equal. Sorry for the typo error. 39 minus 11d equal to 39 minus 11 equal to 4d. So the resulting equation then, we have 39 minus 11 equal to 28. By dividing both sides by 4, so therefore the common difference is 7. Now, since the common difference is 7, we are now ready to find the second term. So we have this one. A sub 3 is equal to 11 plus 3 minus 1 equal to, or times 7, which is the common difference. So therefore, the answer will be a sub 3, 11 plus 14 equal 25. Next one. The first term of an arithmetic sequence is 2, while the 18th term is 87. Find the common difference. So again, based on the formula, a sub n equal to a sub 1 plus the quantity of n minus 1 times d. So substituting the given, the last term is given, which is the 18th term, equal to 2, which is the first term, plus 18, because they are 18th term, minus 1 times d. So again, we're looking for the common difference. Simply substitute the given information in the equation. 87 equal 2 plus 7d. Again, applying the addition property of equality, we need to subtract or add negative 2 to both sides of the equation. So the resulting equation then will be 87 minus 2 equals 17d. So therefore, we have now 85 equal to 17d. Dividing both sides of the equation, so we have d is 5. The second one is, or the third problem is about geometric sequence. So in this given, you were asked to find the sum Find the sum of the geometric sequence where the first term is 3, the last term is 46,875, and the common ratio is 5. Now, based on the given problem, we don't know yet what or how many terms are there. So since the first term and the last term is only given. So we have to find first the number of terms before we can find the sum. By simply substituting in the formula, a sub n equal a sub 1 times r raised to n minus 1. So again, since the last term is given, which is 46,875, equal 3, which is the first term, times the quantity of 5, which is the common ratio, raised to n minus 1. Now, to be more simplified, the given equation, we need to divide first the equation by 3. So by dividing both sides by 3, we come up with 46,875 divide that by 3. It will give us 15,625 equal 5 raised to n minus 1. Now, what will be the next? So our next step is we need to express both sides of the equations by base 5. Now, if we're going to express 15,625 to base 5, it will give us 5 raised to 6 equal 5 raised to n minus 1. So since we have a common base, which is 5 now, we can cancel the common base, so which is 5. So the resulting equations give us 6 minus n, or 6 equal n minus 1. Again, by simply applying the addition property of equality, we need to add both sides of your equation by positive 1. So the resulting equation, we have 6 plus 1 give us 7, and definitely negative 1 plus 1 will give us 0. So therefore, n equal to 7. So since we know already the common ratio, we are now ready to find the sum of the first 3 terms of a geometric sequence by simply using the formula S sub n equal a sub 1 times the quantity of r raised to n minus 1 all over r minus 1. Again, plugging all the informations given, since we know already n what the value of n is, so we have S sub n equal the times or equal a sub 1 times the quantity of r raised to n minus 1 all over r minus 1. Substituting all the value in the given equation, a sub 1 is the first term, which is 3, times the quantity of 5, which is our common ratio. We were able to find already n, which is 7, minus 1 all over 5 minus 1. So therefore, if we're going to extract 5 raised to 7, it will give us 78,125. But we need to minus 1. So that will give us 78,124. Multiply that by 3 before we're going to divide that by 4. So it will give us 34,372 all over 4. So what will you do next in order for you to find the sum of the geometric sequence if the first term is 3 and the last term is 46,875? We need to divide that by 4. So therefore, the sum of the geometric sequence if the first term is 3 and the last term is 46,875 is 58,593. Next problem. So in the problem number 4 under sequences, there are 2 conditions given. Find the first 3 terms of geometric progression whose sum is 42 and whose product is 512. So what are the 2 conditions given in the problem? Sum is 42 and the product is 512. Now, so the first thing that we have to do first is we need to find what are the terms, right? So by simply getting all the information, let us consider first the second condition, which is the product. So if we denote the first 3 terms of the geometric sequence as or are, A over R, A, and AR are the first 3 terms. Let us use this one to find the product. Applying the laws of indices or the laws of exponent, we multiply the first three terms. A over R, multiply that by A, times AR is 512. Again, by applying the laws of exponent, A times A, it will give us A cube. Because if we multiply the same base, equal to the base and the sum of their powers or exponent. So definitely the R is cancelled out. Now, the resulting equations will be A cube equal 512. Then what will you do is we need to extract cube root to both sides of your equation. So since 512 is a perfect cube, therefore the value of A is 8. This is not yet the answer. We just only find A. So we need to find first R, or simply the common ratio. Going back with the first condition, which is the sum of the first three terms. So since we represent A over R, A and AR are the first three terms of the geometric sequence. Let us now find the sum. As we know that when you say sum, that means we need to add the first three terms. And then substitute the computed value of A while ago, which is 8. So therefore, A over R plus AR is 42. If we're going to substitute A in the given, so we have A, 8 over R plus 8 plus 8 over R plus A of 8R equal to 42. Simplifying this one, it will give us 8R squared minus 34 plus 8 equal to 0. Because we need to clear off the fraction by simply multiplying all the member of the equations by R. And then write the answer into a standard form of a quadratic equation in the form of ax squared plus bx plus c equal to 0. But you can see 8r squared minus 34r plus 8 can be simplified again because there is a common factor with regards to the member of the quadratic equation, which is 8, negative 34, and 8 by simply dividing all those by 2. So we come up with 8 divide that by 2 is 4. 34 divide that by 70 by 2 is 17, and 8 divide that by 2 equal to 4. Now, we have 4r squared minus 17r plus 4 equal to 0. In the previous topic discussed by Sir Elmer Isla, you were able to learn already the techniques. So we have the pyramid techniques. So in this the pyramid technique, in this type of factorization, it's better to apply those techniques because the one is very helpful, especially if the numerical coefficient of the squared term is not 1. So I just want to give an emphasis with regards to the sign. Remember, in factorization, if the middle term is negative and the last term is positive, both factors are negative. I'll repeat. So always remember in factorization, if the middle term is negative and the last term is positive, both factors are negative. Now, if we're going to factorize 4r squared minus 17r plus 4 equal to 0, then we have 4r minus 1 times the quantity of r minus 4. So by simply applying also the lesson that you learned under Sir Elmer, we need to equate that or its factor into 0. So splitting the factors we have now, consider the first factor, r, the first r or r sub 1 equal to 1 over 4 and r equal to 4. Now, to double check our answer if it is correct, if r is 1 over 4, the first three terms of the geometric sequence are 32, 8, and 2. To double check if the answer is correct, we just simply get the sum. What is 32 plus 8? 40. Plus 2, 42. So it satisfied the first condition, which is the sum of the first three terms is 42. If we're going to multiply the three terms of the geometric progression, 32 times 8, it will give us 256. Multiply by 2, it will give us 512. So since our answer satisfied both conditions, then the answer is correct. How about the second value of r? Let us find out. If r is equal to 4, the first three terms are definitely 2, 8, and 32 because we substitute that by A over R equal to 2, or 8 divided that by 4 is 2. And then A, definitely that is 8. 4 times 8 is 32. Again, let us double check if the answer also satisfied the given two condition. Sum of the three, 2 plus 8 is 10, plus 32 is 42. The product, 2 times 8 is 16. Multiply that by 32, it will give us 512. So therefore, the answer, both answers are correct if the value of R is 1 over 4 and another value is 4. Okay. So those are example questions under sequences. So let's have some questions under polynomials. Find the value of k for which x squared plus the quantity of k minus 1x, multiply that by x, sorry, plus k squared minus 16 is exactly divisible by x minus 3 but not divisible by x plus 4. Let us solve first the first problem. So remember, based on the given information, it is exactly divisible by x minus 3. Means to say, if a given polynomial is exactly divisible by a given monomial, that means the remainder is 0. There are two conditions. We need to find the value of k for which the given polynomial is exactly divisible by x minus 3, but not divisible by x plus 4. Now, how to solve this problem? In order for you to solve this problem, so what will you do? We just only use substitution method. Let us substitute first x minus 3. So that means the value of x equal to 3. Equating the factor into 0. So therefore, the first value is 3. Again, substitute that. Since I told you, if a given polynomial is exactly divisible by a given monomial, then the remainder must be 0. Substituting that in the given equation or the given polynomial, 3x squared plus the quantity of k minus 1 times 3 plus k squared minus 16. As we know that 3 squared means to say 3 times 3, it will give us 9. By applying the distributive property, should I say, 3 times k is 3k, 3 times negative 1 give us negative 3, plus k squared minus 16 equal to 0. Combining all like terms, so we have k squared plus k and then all the constant. If we're going to add the negative, we have negative 3 and negative 16, it will give us what? Negative 19, and 9 is positive, simplifying that. As we know that adding integers, if they are unlike sign, we need to subtract the absolute value and follow the sign of the bigger number. So simplifying that, again, we have x squared plus 3k minus 10 equal to 0. Now, this is another factoring method. I just want to put emphasis again. If the middle term is positive and the last term is negative, the bigger factor of the constant, which is negative 10, must be positive. So therefore, you learned that also under the discussion of Sir Elmer Isla a while ago. So factorization or factoring the given quadratic, so the factors will be x, or the quantity of x k plus 5 times the quantity of k minus 2 equal to 0. Applying the factor property, split the factors. So we have now k plus 5 equal to 0, k minus 2 equal to 0. Then the value or the first value of k is negative 5 and the second value is 2. Now, to double check with the given polynomials, when k is 2, substitute in the given polynomials, what will be the remainder? So by simply substituting that in the given polynomials, it will give us negative 5 minus 1. Then substitute the value. It will give us 3 squared minus 6 times 3. Okay, when x is 3, it will give us what? 0. So that means if the value or if the value of x is positive 3, then the remainder is 0. So therefore, the value of k must be 2 when the given polynomials is exactly divisible by 3. Then, how about if the given is when it is divided by x plus 4? So that means the value is negative 5. Oh yeah, the value of x is negative 4. Substituting that in the given polynomials, let us find out if the remainder is 0. So since the remainder is 49, so that means the value of k is negative 5. So we can conclude that the given polynomials is exactly divisible by x minus 3 when the value of k is 2 and not divisible by x plus 4 when the value of k is negative 5. Next problem. So the expression x cubed plus ax squared plus bx minus 7 has the same remainder when divided by x minus 2 and x plus 1. So again, the given expression has the same remainder when it is divided by x minus 2 and x plus 1. Given that, so the second condition is given that the remainder when the expression is divided by x minus 2 is 3. Find the value of a and of b. Now, by taking into consideration the given condition in the problem, so we have this one. Let us substitute first x plus 2. To formulate our equation, we need to substitute x when the value of x is 2 and the value is negative 1 on the given polynomial. So simplifying that by substitution, let us substitute first when x is 2 in the given polynomial. So we have x squared, substitute the value, that will become 2 squared plus ax squared. So since x is 2 plus b times 2 minus 7 equal to 3. Simplifying that, it will give us what? 4 plus 4a plus 2b minus 7 equal to 3. Combining all the constant, negative 7 and positive 4 will give us what? Negative 3. So, by simply applying the addition property of equality, we're going to add positive 3 to both sides of the equation. It will give us what? 4a plus 2b equal to 7 minus 4 plus 3. So, we have now 4a plus 2b equal to 6. So, since we have two values of x, which is positive 2 and positive 1, the first we did is we just simply substituted the value of x when x is 2 in the given polynomial. This will serve now as our first equation. This is not yet the answer because we were not able to find the value of a and the value of b. The one that we find is the first equation when x is 2. Now, let us find out our second equation when we substitute the value of x when x is negative 1. So we have now, again, applying the substitution method in the given polynomials. Negative 1, or the quantity of negative 1 squared. So remember this. So since the value of x is negative 1, because negative 1 squared is different from the quantity of negative 1 squared. So be careful with the sign, because if you didn't put the quantity of negative 1 squared, it's simply negative 1 squared, is still the answer is negative 1. But this is different. The quantity of negative 1 squared plus a times the quantity of negative 1 squared plus b times the quantity of negative 1 minus 7 equal to 3. So simplifying our equation or polynomials, we have now, of course, negative 1 times negative 1, it will give us what? Positive 1. And then we have negative 1 squared, or the quantity of negative 1 squared, multiply that by a, it will give us a. Then b times negative 1 will give us negative b minus 7. Simplifying this, it will give us a minus b equal 7 minus 1 or minus 1 plus 3 by simply transposing or simply adding the additive inverse of 1, which is negative 1, to both sides of the equation. So therefore, the left side become a minus b equal a minus b equal to 9. So this will serve now as our equation. So we are now ready to find the value of a and b by simply equating 1 and 2. When we say equating 1 and 2, that means we need to equate equation 1 and 2. So the result will be 4a plus 2b equal to 6, which is our first equation. And our equation is a minus b equal to 9. We cannot simply cancel any of the variable unless they have the same coefficient. Now, in this solution, I decided to cancel b by simply multiplying all the member of your equation or the second equation by 2. So the resulting equation now, we have 2 times the quantity of 2 a minus b equal to 9. So we multiply all the member of your second equation by 2. We come up with 2a minus b equal to 18. So therefore, by equating the two equations, we can now eliminate b. 4a minus plus 2a equal to 6. Definitely, the variable b will be eliminated. Positive 2b minus 2b equal to 0. Then equal, so 6 plus 18 is 24. So therefore, by equating the equation or simply solve for a, divide both sides by 6. So therefore, a equal 4. Now, if you want to go back with equation 2, there is a common factor. There is another alternative solution for that. You can see our first equation a while ago is 4a plus 2b equal to 6. So you can simplify that also by simply dividing all the member of our equation by 2. So since 2 is a common factor of 4, 2, and 6. So you will get the same answer. Now, since we know already the value of a, which is equal to 4, we are now ready to find the value of b. So in solving for b, it's either you use the first equation or the equation 1 or equation 2, you will get the same answer. So in this case, I use equation 1, which is 4a plus 2b equal to 6. So what will you do? Substitute the value of a in the given equation. 4 times 4 plus 2b equal to 6. 4 times 4 equal to 16 plus 2b equal to 6. Again, by simply applying the addition property of equality, we're going to add negative 16 to both sides of our equation. So the resulting equation now, we have 2b equal 6 minus 16. Definitely, 6 minus 16 will give us a negative. So 2b equal to negative 5. Therefore, divide both sides by 2. The value of b is negative 5. Okay. Next question is all about circles. So under circles, Teacher Elmer discussed the point of tangency. So in pre-calculus subject, especially when you were in calculus, when you say point of tangency in relation to the center of the circles, they are said to be perpendicular. But in pre-calculus or calculus subject, they will not tell you that you will not encounter the word perpendicular. Most of the time, you will encounter the point of tangency or normal to the curve. So when you say normal to the curve and tangent to the curve, means to say the curve as well as the line intersect at one point. So the relationship between the point of tangency to the center of the circle are said to be perpendicular. Okay, let's have the first problem. Write the equation of the circle in the standard form given the center is negative 4 and it is tangent to the line. Y is negative 4x minus 30. Now, again, I just want to put an emphasis with regards to the relation between the point of tangency to the center of the circle. Now, the relationship between the point of tangency to the center of the circle are said to be perpendicular. And as we know that, if two lines are said to be perpendicular, we need to consider the gradient or the slope of a line. If two lines are said to be perpendicular, so the product of their slope is negative 1 or simply the negative reciprocal. Taking into consideration the given, The center is given, which is -4 and +3. So going back with our problem, you can see if we will consider the slope of the line that is said to be tangent to the circle, -4x minus 30. So in this equation, y is -4x minus 30. The slope is, or the gradient is -4. So what is the negative reciprocal of -4? 1/4. So let us proceed to the solution. Now, let us use the center of the circle to find the point of tangency. So we have now, I use the point or the center of the circle to find the y as well as the x coordinate. So we have, simplifying that, distributive property, y minus 3 equal 1/4 multiply that by x will give us 1/4x, or simply x/4. So definitely 1/4 multiply that by +4, it will give us 1. So again, applying the addition property of equality, we're going to add +3 to both sides of the equation. So the left side will remain now y equal, so add the positive side to the right side. So simplify that, it will give us x/4 plus 1 plus 3 give us 4. So again, clearing our fraction, it will give us this one. Therefore, the temporary value of y is x plus 4 all over 16. Again, this is not yet our answer. Going back to the equation of a line that is said to be tangent to the center of the circle, let us substitute. We are now ready to find the value of x in order for us to find the point of tangency to the center of the circle. Using the equation of a line which is said to be tangent to the center of the circle, we have now y is -4x minus 30. Substituted the temporary value of y, which is x plus 16 all over 4. So we have now x plus 16 all over 4 is -4x minus 30. Clearing of fraction. In order for us to clear the fraction, what will you do is we need to multiply all the member of your equation by 4. So simplifying further, it will give us x plus 16 equal -16x minus 30. So what will you do? Separate the variable x. Separate the variable x. So what will you do? Or simply applying the transposition. As we know that when we transpose from one side to another side, negative will become positive and positive will become negative. So by doing so, let's have separate the variable x. So we have now x plus 16 equal -120. 16 will become negative. Simplifying that, x, that means 1x plus 16x will give us 17x equal -36. Simplifying further to find the value of x, we need to divide both sides of the equation by 70. Negative, positive, division will give us -8. Therefore, the x coordinate of the point of tangency to the center of the circle is -8. So to find the y value now, or the y coordinate, solving for y, substitute the value of x in the equation. We have y is x plus 16 all over 4. So the computed value of y is -8. Again, -8 plus 16, positive, negative, addition. We need to subtract and follow the bigger side, the sign of the bigger number, which is positive. So -8 plus 16 will give us 8. Divide that by 4, therefore y is 2. Okay, this is not yet the answer because we're looking for the equation of the circle. Radius, sorry, we need to find first the radius. Applying the distance, what are the points that will be used? So the center of force as well as the point of tangency. So therefore, the point of tangency to the center of the circle are -8 and 2. These are the points used in order for us to find the length or simply the radius of the circle. By doing so, let us substitute the value. Our x sub 2 is negative 8 plus the positive 4. Again, simplifying further, negative 8 plus 4 squared. So negative 8 plus 4, it will give us negative 4. Square of that. And then 2 minus 3, which is the coordinate of the center as well as the point of tangency. Simplifying, we have square root of 16 plus 1. So 16 plus 1 give us the square root of 17. So what will be the representation of this? So this will serve as the radius of the circle. Now, we're now ready to find the equation of the circle if the point of tangency are negative 2 and 8 having a center of negative 4 and positive 3. So we have equation of the circle now, the quantity of x plus 4 squared plus the quantity of y minus 3 squared equal to 17. Next, if we're going to draw the graph of the circle, so this is it. So the point of tangency is at negative 8 and 2. Center, negative 4 and positive 3, and having a radius of 17, or square root of 17. Okay, there you have it. That line represent the equation y is negative 4x minus 30, and the entire the circle having a center of 4 and 3, and the point of tangency is negative 8 and 2. Next problem. Okay. Find the equation in the form of x squared plus y squared plus cx plus dy equal to e of the circle that has the point 1 and 8 and negative 5 and 6 as the endpoint of the diameter. So remember, endpoint of diameter are given, which is 1 and 8, 5 and 6. So what will you do first is we need to find the length of the diameter by using the points 1 and 8, 5 and negative 6. So using again the distance formula, substitute the coordinate of the endpoint of the diameter. X sub 1 serve as 1, x sub 2 is 5. Or you can do the other way around. X sub 2, you will get the same answer. So substituting all those values, so we have this one. So the length of the diameter is square root of 212. So we can simplify square root of 212, factorize 212 where one of the factor is a perfect square. So the factor will be 4 times 53. So since 4 is a perfect square, therefore the length of the diameter is 2 square root of 3. Again, what is the relation between the radius as well as the diameter? One diameter is 2 radii or radii. So what will you do to find the length of the radius? We simply divide this by 2. So again, so since the end of the diameter is given, we need to find first the coordinate of the center using the midpoint. So in the presentation that I did a while ago, I presented also the formula on how to find the midpoint of the line segment. So in terms of x, we need to consider x sub 1 plus x sub 2 all over 2, or you can do the other way around, x sub 2 plus x sub 1 all over 2. You will get the same answer. Now, so since endpoint of diameter are given, we need to consider the coordinate of x, 5 plus 1 all over 2, and in terms of y, negative 6 plus 8. So therefore, we have 3 and 1. So by simply substituting that in the equations of a circle, if the center is at point A and B, so substituting the center as well as the radius. So we have now this one. So again, as I've told you, one diameter is equal to 2 radii. So in order for you to find the length of the radius, what will you do? Since we compute the diameter, which is 2 square root of 3, we just simply divide that by 2. Therefore, the radius is the square root of 3. Again, going back with the equation. you were asked to write in the form of x squared plus y squared plus cx plus dy equal to e. Do not leave our answer in this case because remember in a given test, instruction is already a part of the test. So we need to expand this one. So to find the equation in the form of x squared plus y squared plus 6 plus dy equals to 3, we need to expand that. Again, during the presentation of Sir Elmer Isla, presented on how to square binomials. In squaring binomials, so what will you do? You square the first term minus or plus twice the product of the first and the second and square the last term. Applying that special in squaring binomials, so we have x squared minus 6x plus 9 because if we're going to square x, that will give us x squared. Twice the product of the first and the second. So what is the first term? X. What is the second term? 3. So 2 times 3 times x, it will give us negative 6x because the sign in between the two is negative. And squared of negative 3, it will give us positive 9. Doing the same procedure on the quantity of y minus 1, it will give us y squared minus 2y plus 1 equal to 59. Simplifying further, it will give us, transpose all the constant to other side, 1 plus 9, it will give us 10. Applying the additive inverse or applying the addition property of equality to both sides of our equation, 10 will become negative 59 minus 9 or minus 59 minus 10, it will give us 49. So therefore, the equation of the circle now, if the endpoint of the diameter are 1 and 8 and 5 and negative 6 in the form of x squared plus y squared plus 6 plus dy equal to 3 equal to e is x squared plus y squared minus 6x minus 2y is 49. Again, using those informations in order for you to graph the circle having endpoint of the diameter as 1 and 8, 5 and negative 6. So this is how the graph look like. Okay. Next problem. So in this type of problem, it's the other way around. So a while ago, you were asked to find the point or the point of tangency, and then we were able to find the equation of a circle. So this is the other way around. Based on the given information, you were asked to find the equation of a line in the form of ax plus by equal to c, and it is said to be tangent to the circle x squared plus y squared equal to 25 at point 3 and negative 4. Now, it's very easy by observation that the center of the circle is at the point of the origin because the equation of the circle is in the form of x squared plus y squared is equal to r squared. Now, definitely, the center of the circle is at the point of origin. By doing all the information, we need to find first the gradient or the slope, and it's said to be tangent to the circle at point 3 and negative 4. Now, so since the center of the circle is at point 0, 0, let us find first the gradient or the slope. Using using the information and using the formula of the slope, we have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 equal, again, using those points, the center is at the point of origin, 0, 0 is the other point, it will give us a negative 4 over 3. Negative 4 over 3 is the slope of the line. But since that is tangent to the circle, tangent, point of tangency is the one that we are looking for, or given information, that means the point of tangency is said to be perpendicular to the center of the circle. As we know that the gradient of two lines that are said to be perpendicular is the negative reciprocal or the product of their slope is negative 1. So since the gradient or the slope is negative 4 over 3, and the negative reciprocal of negative 4 over 3 is 3 over 4. We are now ready to find the equation of the line in the form of ax plus by equal to c, using the information y minus y1 equal to the slope times the quantity of x minus x of 1. Okay. Now, using the point of tangency, so we have negative 4 as the y coordinate and 3 as the x coordinate. Substitute that in the given equation. So we are now y negative times negative, it will give us positive 4 equal, using distributive property, 3 over 4 times the quantity of x minus 3, it will give us 3x over 4 minus 9 over 4. Simplifying further, clear off fraction, we need to multiply both sides of your equation by positive 4. So therefore, 4y minus 3x is negative or equal to negative 25 because negative 9 and negative 16 are like sign. We need to add and copy the common sign. So the resulting we have 4y minus 3x is negative 25. But as you can see, you were asked to write that in the form of ax plus by equal to c. Now, by observation, the coefficient is negative 3. So that means we need to do something by multiplying all the member of our equation so that you were able to express the given equation or equation of the line that is said to be tangent to the center of the circle in the form of ax plus by equal to c. Multiply all the member of our equation by negative 1. So the answer will be negative times the quantity of 4y minus 3x minus 25. It will give us 3x minus 4y equal to 25. So therefore, this is our answer. Okay. Another problem in circle. The diagram shows two circles that is represented as C sub 1, which is the first circle, and circle 2 that is represented as C sub 2. As its center at the origin, O. Circle 2 passes through O and has its center at Q. So remember, there are conditions given. Circle 1 as its center at the origin. So in the diagram shown, the circle 1 or C sub 1 represent the circle 1, which is the big one, the big circle. And circle 2 or C sub 2 that is represented at the small circle. Okay. The point 8 and negative 6 lies on both circle. At OP is the diameter. So that means OP is the diameter of the big circle. Now, the question is, the small circle, OP represent as the diameter of the small circle. Now, you were asked to find the equation of circle 1 as well as circle 2. Let us do it one at a time. So since the center of the big circle is at the point of origin, so let us now solve distance between 2 points again using all the informations given. So since the center of the big circle, which is represented as C sub 1, is at 0, 0, and having a radius, the coordinate of the point P as 8 and negative 6. So to find the length of line segment OP, substitute the coordinates. So we have 8 minus 0, it will give us what? 8. 8 squared. Then negative 6 minus 0, it will give us negative 6. The square of that. The square of 8 is 16. The square of negative 6 is give us 36. Square of 8 is 64. 64 plus 36 is 100. The square root of 100 is 10. So therefore, the radius of the circle 1, which is represented as C sub 1, the center is at the point of origin, and the point at point 8 and negative 6, the radius equal to 10. Okay, so therefore, we have that one. Sorry for that. So the equation of the circle 1. So a type of error, it should be x squared plus y squared equal to 100. Okay, how about the circle equation of the circle 2? So going with that type of error, please bear with me. It should be x squared plus y squared equal to 100. Okay, equation of circle 2. So as you can see, the point or the line segment OP serve as the diameter of the small circle. So therefore, to find the center of the circle or the midpoint serve as the center of the small circle or circle 2. So we have now 8 plus 0 divided by 2, negative 6 plus 0 all over 2. So therefore, the midpoint now of the circle 2, circle 2, we have 4 and negative 3. So this will serve as the coordinate of the center. So to find the radius, again using the distance formula, we have this one. The radius of the circle 2, we have 5. Substituting that to find the equation of circle 2, we have now the quantity of x minus 4 squared plus, bear in mind, negative sign, negative, that is very important. So you need to indicate negative 3 because if you will not put a parenthesis with that, you might get a wrong answer. So simplifying further, we have now the quantity of x minus 4 squared plus the quantity of y plus 3 squared equal 25. Okay. Sorry. So sorry about my my PowerPoint. So again, this one, another problem for a circle. The diagram shows two circles, circle 1 and circle 2. The center of the circle 1 is at 2 and negative 2 and 2 and negative 2. Circle 2 passes through A and meets a circle 1 at 2 points. One of which is B or point B. The coordinate at point B is 6 and 0. So first question, find the equation of circle 1. Second question, find the equation of perpendicular bisector. So remember, perpendicular bisector of the chord AB. Given that the radius of circle 2 is 5 units, find the coordinate of the center of circle 2. And also, you were asked to find the equation of circle 2. Okay, so this is the solution. Equation of circle 1, taking into consideration the given points. Let us find first the radius. So the radius of the circle 1, using those coordinates, so we have the square root of 6 minus 2 squared plus the quantity of 0 minus parenthesis minus 2 squared. Simplifying that, 6 minus 2 is 4. 4 squared will give us 16. And definitely, negative times negative equal positive. Simplifying further, so we have 16 plus 4 give us 20. And the square root of 20 can be simplified or serve as already the radius. So therefore, the equation now of circle 1, substituting the center as well as the radius, the quantity of x minus 2 squared plus the quantity of 4 plus 2 squared is equal to 20. Definitely, the square root of 20 can be simplified at 20 because if we're going to extract the square, the square root of 20 will give us 20. Okay, we are now ready to find the perpendicular bisector of the chord AB. So taking into consideration the gradient. So the coordinate are to be used 2 and negative 2, 6 and 0. Simply find first the slope or the gradient of the perpendicular bisector of AB, which is equal to 1/2. Applying the formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 on how to find the gradient. So since the points are said to be perpendicular, or you are looking for the perpendicular bisector, the equation of the perpendicular bisector of the chord AB, we need to consider the negative reciprocal of 1 over 2 to determine the slope of the perpendicular bisector AB. So since the gradient or the slope that we were able to compute is negative 2 or positive 1 half, and the negative reciprocal of 1 half is negative 2. So let us now find, first we need to find the midpoint of AB by simply applying the midpoint formula in terms of x sub 1 plus x sub 2 all over 2, or you can do the other way around, x sub 1 plus x sub 2 square over 2 in terms of y sub 2 minus y sub 2 plus y sub 1 all over 2, or the other way around also, you can use y sub 1 plus y sub 2 all over 2. So simplifying further, 2 plus 6 is equal to 4 divided by 2 is 4. Negative 2, of course, over 2, negative positive division will give us negative 1. So therefore, the midpoint of the line segment AB is 4 and negative 1. So the equation of the perpendicular bisector can be written in the form of y minus 2x plus c. So we need to find first c. Applying or substitute the computed value using 4 and negative 1 in the equation y is negative 2x plus c using points 4 and negative 1. So our y is negative 1 and our x is 4. Simplifying further, so we have now negative 4 times negative 2 times 4 is negative 8. And since the value of y is negative 1, again, simplifying that, it will give us a value of, the value of c is 7. So, by simply substituting all the given information that we were able to compute the value of c, and we were able to find the gradient that is said to be perpendicular bisector of AB. So the equation of the perpendicular bisector of AB is now y is negative 2x plus 7. Okay. And the last one about, given that the radius of the circle 2 is 5 units, find the coordinate of the center of the radius. Now, so since the perpendicular bisector of the chord AB passes through the point, the center at circle 2, and the center is, the coordinate of the center are x minus 2x plus 7. So in here, we need to find first the coordinate. So since x and negative 2x are given, so what will you do? Applying distance formula again, and the points 6 and 0, and simply the other coordinate is negative 2x plus 7. So using the distance between center and B, we have now the radius is given, the square root of the quantity x minus 6 squared plus the negative 2x plus 7 squared equal to 5, because the radius of the circle 2 is given. So we have now, definitely, that will give us what? The quantity is squaring both sides of the equation. Definitely, the square root sign will be cancelled. The square root of 5 is 25. So we have now the quantity of x minus 6 squared plus the quantity of negative 2x plus 7 squared equal 25. Applying squaring binomials, square the first term, minus twice the product of the first and the second, plus square the last term. So simplifying this, it will give us x squared minus 12x plus 36, 4x squared minus 2x plus 49 minus 25 is equal to 0. Combining all like terms, so we have now 5x squared minus 40x plus 60 equal to 0. Now you can see our quadratic equation, 5x squared minus 40x plus 60 equal to 0, there is a common factor. So what is the common factor of 5, 40, and 60? 5. So we can reduce our quadratic equation as x squared minus 8x plus 12. Now, again, as I've told you in the previous example, if the middle term is negative and the last term is positive, both factors are negative. So factorize that one, it will give us this. So equating its factor into 0, x is 2 and x is 6. Why I put rejected positive 2? Based on the given diagram, it is impossible that 2 can be the coordinate of the center of the circle. So that is the reason why we need to take the x coordinate as 6. So to find the y ordinate, so substituting x equal to 6 in the given equation, y is negative 2x plus 7. So substituting that, negative 2 plus 6 is negative 12 plus 7 give us negative 5. So therefore, the coordinate of the center of the circle 2 is negative 6, positive 6 and negative 5. Okay. So, given that the radius is 5, we are now ready to find the equation of the circle. So, since we know already the center of the circle, which is at at 6 and negative 5, let us substitute that in the standard form. If the center of the circle at point A and B, so we have now the quantity of x squared, the quantity of x minus 6 squared plus the quantity of y plus 5 squared is 25. So therefore, this is now the equation of the circle. Circle 2, if the radius is 5 units and the center is positive 6 and negative 5. So, one more problem. Okay, so this one is very easy. I think you know how to do this one. I just want to take the last problem. If tangent theta is 2 over 3 and theta is in the third quadrant, you were asked to find the cosine theta. I'll repeat. If tangent, this is the last problem. If tangent theta is 2 over 3 and theta is in the quadrant 3, find the cosine theta. As we know that in a quadrantal angles, when you are on the first quadrant, all positive. Second quadrant, sine positive, the rest are negative. Third quadrant, tangent positive, the rest are negative. And on the fourth quadrant, cosine positive, the rest are negative. Now, by illustration, using the Pythagoras theorem or formula, so this is the solution. I just plus the solution of problem number 1. That one is very easy. Okay, there you go. And this is the one that I'm telling you. In quadrant 3, only tangent positive, the rest are negative. So under quadrantal angles, as I've told you, we just follow the ASTC, first quadrant, all positive. Second quadrant, sines positive, the rest are negative. On the third quadrant, tangent positive, the rest are negative. And on the fourth quadrant, cosine positive, the rest are negative. Now, by applying the Pythagorean theorem, state that a squared plus b squared equal to c squared. That means the squared of the longest side in a right triangle, which is the hypotenuse, is equal to the sum of the squared of the two shortest side. By representation, tangent is given. So when you say tangent, that is opposite over adjacent side. Now, if theta is the reference angle, by representation on the diagram, opposite side is 2 and the adjacent side is 3. Let us find first the hypotenuse, which is c squared. So, we have now 2 squared plus c squared equal to c squared. 4 plus 9, because 2 squared is 4, 3 squared is 9. Then plus the 2, get the sum of 4 and 9, that is 13. So, therefore, by simply extracting the square root of both sides of your equation, the value of c is the square root of 13. So, you were asked to find cosine theta. That means cosine, since tangent is on the third quadrant, so therefore the cosine must be negative. Cosine ka means to say adjacent over hypotenuse. So since we are on the third quadrant, that means the value of cosine must be, or the ratio of the adjacent and hypotenuse must be negative. So adjacent is 1, 3. All over, the hypotenuse is square root of 13. But since we are on the third quadrant, so the ratio will be the negative 3 over square root of 13. So since the denominator is in radical sign, we need to rationalize our denominator by simply multiplying the numerator and denominator by the square root of 3. So therefore, cosine theta now, we have negative 3 all times square root of 13 all over 13. So I think that's all. I hope I you learn something about my presentation. So in this time of pandemic, it's better to share what we have, and it's nice feeling to share. So thank you very much. God bless us all and keep safe.
Okay, let's proceed to our quiz. Okay, so we have 114 participants. Thank you so much, sir. We are
Thank you very
impressed
much,
by your
ma'am.
marvelous presentation, sir. Thanks for sharing your knowledge and expertise. I am sure that this session is essential for our audience because of the intelligible knowledge you have shared. Thank you so much, sir. Thank you. Wonderful presentation. Okay, so the 123. Oh, question number one. Okay. The holistic calculus is used to find the least measurable consequence. Oh, true. 82%, while false 18%. Okay. Mhm. Wow. Question number two. Isaac Newton and Gottfried Leibniz are both credited with working on calculus. True or false? Okay, true. What is an operation in algebra? Parentheses and exponents? Add, subtract, divide, or multiply. Very good. 61% got the correct answer. Mhm. What are letters in algebra called? Okay, the correct answer is variables. 92% got the correct answer. Next question, how can we access algebranation? Okay, 10% got the correct answer using the standard. Okay. Next, in relational algebra, selection can produce duplicates. True or false? Okay, the correct answer is false. And 26% got the correct answer. In relational algebra, what are the operands and operators? Very good. 37% got the correct answer. Next, techniques of calculus and linear algebra to study problems in geometry. Okay, 34% got the correct answer. Linear algebra, calculus, and probability are essential for AI. Okay, true or false? Okay, 91% got the correct answer. Relational algebra and relational calculus are equivalent in expressive power. Okay, very good. 67% got the correct answer. Okay, congratulations, Josel Bartolai. Second, Kevin Seraphis, Seraphica, and Micah H. Please give your complete name, write it in our chat box. Congratulations to our first, second, and third winner for tonight. Good job. Thank you so much. Please write your name, your complete name in our chat box. Congratulations. Very good.
Hello.
Congratulations to the three winners. Okay, Sir
Hello.
Showman.
Can you hear me?
Yes, sir. Yes, sir.
Hello.
Yes, sir. We can hear you, sir.
Oh, thank you. Dear participants, congratulations first, second, third for quiz competition. He has quiz competition. Those three, first, second, third, are requested to contact our page inbox with your full name immediately that we can issue the certificate within time. And one more thing, we already shared certification link into we already pinned certification link to this comment, this slide.
Mhm.
If you want, then we can move for Q&A, and if you are not agree with Q&A, so today we are going to stop here because it's near about 11 at Philippine.
Yes.
So I think it depends on you. If you guys wants to join Q&A, then we can go for Q&A. Just put in the your opinion in the comment box.
In the comment box. Please
What do
let
you
us
want?
know. Yes.
If you
Please let
want,
us
we'll
know.
go for Q&A. Our speakers are ready here. If you want, then we will go for Q&A. Otherwise, we will stop here for today's session.
Okay. Please let us know in the chat box if you want to have Q&A tonight. Thank you, IGP. Congratulations to all the winners.
Actually, no one
Okay.
wants for Q&A. It's time to rest. Yes, thanks. That's
Thank
point.
you.
So today no more. It's already we decided, but
Yes,
we
let's take
always
a rest
follow
of
our
all.
participants' opinion. We always follow our
Yes.
participants' opinion, so that's the reason we asked
Mm,
to you. We already
yes.
pinned the certification link into this live, and I opened I already opened our certification link at least 30 minutes before, because I know that
Mm,
some of them are well known how to claim certificate. So they already lots of participants already claimed their
mm,
certificates. I
yes.
already shared the certification link into comment section, and it's a short notice for you,
Mm.
those who
Today's
are new
program
here.
name.
This is the today's program name, Algebra cum Calculus, and certification link. This is the certification link which I already shared with you in comment section and also pinned in the comment box. Instruction: certificate code not required. Mind it, certificate code not required. Certification link now available in comment box and pin comment. Okay. If you are not able to click the link, please browse www.eduigp.com, because we saw that lots of participants join with us through share, because lots of participants already shared this live and some of them all are joined through share post. So from share post you can't able to click on link. That's true. So on that basis, what you have to do, you have to browse www.eduigp.com. Then you can find today's detailed seminar title and get enrolled. If you are new, then you have to create your account first. After that, login and then enroll, and at the same button you can claim your certificate. And one more thing, then these certificates are auto downloadable, so you don't need to download anywhere. So you have to check your file manager. If there's nothing, so you have to update your browser, because our all certificates are auto downloaded.
Okay.
Certification, browse www.eduigp.com. You can find not only today's, you can find total 107 webinars at the same platform, and you can also attend the previous webinars through the program link. You can when you click on the program link, you will directly redirect into live. Just check, this is the button where it's right now enroll. After your enroll, it the same button you click get your certificate, and your certificate code is not required. And this is the certificate. You can verify your certificate from anytime, anywhere. Anyone can verify your certificate, which is very important for professionals.
Yes.
And our next webinar will be held on at 4th June, day after tomorrow. Topic: artificial intelligence and the future of content, with two intelligence professors from Egypt and Iraq. I hope that's enough for today.
Thank you so
And
much.
already with us, we have two speakers together, and Ma'am Rohamina also here. Thank you so
Thank
much,
you,
dear
sir.
sir,
O yan, meron ka na kung certificate ka rin ang may kain.
to share your knowledge.
Ay, hindi tanglig kaya kung may karoon daw.
I think, sir, they understood the topics well.
Thank you so
No
much. See you
questions.
again in the next session. And one more
Thank you
announcement
so
is that
much.
if anyone participants face any kinds of problem to claim certificate, anything, any kinds of problem regarding anything, we have our two core volunteer, not only core volunteer, mm, I named there as a supporter of IGP. One of them, Janet Cablo, and another one is Calvin Linato.
Mm,
They are always ready to support you in comment section. You can also personally knock them, and if you want more support, then you can also contact with our page inbox. No problem. We are always ready to serve you, because without you, IGP is nothing.
yes.
So that's true, and we are here to serve you in every second. Thank you so much, dear sir. One already comment here. For clear explanation, no Q&A. That means your presentation is was so good.
Thank you very much, sir. Good to hear that
Thank you,
also.
sir. That's
For quick
That give us also
that's
explanation.
very good to hear.
it boosts also us our morals if there are positive comments like that.
From Ma'am
So we do,
Marisa.
yeah. So
It's
we do hope
actually
that we can work you
sir,
again in
it's
the
around
future.
11
Yes.
11 p.m. It's
Yes, PM.
late night, so it's late night. Again, first of all, I'm sorry for being late. Actually, not being late. It's already late. So, and still now it's 200 in live right
Yes,
now.
more than
Yes. Yes.
200.
You are still
More than
very much
300.
interested with
More
the
than
topic. Yeah.
300. Yeah, I think they really like the topic, sir.
So that is
Tanjo
the reason why we
email
decide.
not
That's the
working.
reason why, sir, we decided to stop because there are still questions.
Yes, yes, that's true. That's true.
Hope in
Okay.
the future we can work again together with you, sir. It's our pleasure to serve and to share what we know. That is only the fulfillment that we get as a teacher. It's quite fulfilling if you share what you want, your expertise.
Yes,
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 I
that's
I
true.
agree.
Uh,
No worries being late. Sir,
Kelvin Linatok, I'll just request you. Some of them still uh, facing the problem to generate the certificate, like Christian Joy. I think you can help them personally, so they can claim their certificate easily. So no
yes.
problem. We have already two core supporter of IGP in comment section anytime, and you can also inbox them if you want to serve more. Then you can also contact with our page inbox. No problem. We are always ready to serve you.
Yes, yes,
Yes.
yes, please.
Thank you so much, sir.
Our first
Now I am
win.
going. Now I am going to stop here.
Mm.
Thank you so much.
Thank
See you
you.
again.
Thank you so much,
Welcome,
all. Thank
sir.
you.
Thank you very
Hope to
much,
see you
Ma'am
again soon.
Rahimina. It's
You
nice
are
to
welcome,
Ma'am
sir. Thank you
Rohamina.
so
yes,
much.
it's nice
Yes,
to
thank
meet
you
you
so
even if it's
much.
online. To Mr. Showman, sorry.
Yes, Mr.
Yes, Mr.
Showman.
Schumann.
Yes.
He's the man.
Okay. Yes, it's my pleasure, sir, to meet you.
So hope to see
Still,
you and work with you
still
again for
increasing.
another
Still
webinar.
increasing the number of
Yes,
participants.
I. Yes, we have. Oh yeah, more than
Yes, that's the real
200.
supporter. That's the real supporter
Mm.
of IGP.
Um, Josel
Yes.
Bartolai,
And we
our
don't.
first
One
reader,
more thing.
said,
One question,
"No worries
Kathy
being late."
Avila. I'm having database error. No problem. You can claim your certificate tomorrow also. Not only tomorrow,
Okay.
you can claim your certificate day after tomorrow also.
Tomorrow.
So we don't have any restriction to claim to any for your certificate. We don't have any restriction. Hope we can see you, Mr. Strawman. Definitely, all of you can see me directly. No problem.
Yes, sir. We don't even see your face
Thank you
because
I
you
so
didn't
much.
put your
think,
Now I'm
camera.
going to
yeah.
stop here and thank you again.
Okay.